Okay, and here's the last limiting reagent practice problem. So this one has manganese dioxide reacting with hydrochloric acid to produce manganese chloride, chlorine gas, and water. So for this one, our playas are 0.45 moles of manganese dioxide and 48.2 grams of hydrochloric acid, and it's asking us how much Cl2 could be produced. So that means we're going to do the normal grams to moles to moles to grams to figure out how many moles of chlorine gas can be produced. So let's write that, grams to moles. And we're just going to moles, not all the way to grams. Alright, so the first given is 0.45 moles of manganese dioxide, and look at that, hey, they're trying to trick us, but we're way too smart for them. So the question is saying we have 0.45 moles of manganese dioxide, so we're not going to start here on gram island, we're actually starting already on moles. That conversion's been done for us. Trying to trick you into starting there, throw you up, but ain't going to fall for it. So we go right to that moles to moles step. There is, in the reaction, 1 mole of manganese dioxide. And there is 1 mole of chlorine gas. Cancel, cancel, and we're ready to solve already. So what we get from this then, from the manganese dioxide, is we could produce 0.45 moles of Cl2. It's a 1-to-1 ratio from manganese dioxide to chlorine gas, so 0.45 moles of manganese dioxide to produce 0.45 moles of chlorine. Let's do that second one, 48.2 grams of hydrochloric acid, and in this case we are given grams, so we're going to start right here. So this one will be a 2-step process. Alright, so 1 mole of HCl is 36.5 grams of HCl. And if we look up at our balanced equation, there's 4 moles of HCl for every 1 mole of chlorine gas. Ready to solve this out to see how many moles of chlorine gas hydrochloric acid could produce, and it could produce 0.330 moles of Cl2. So using our knowledge of numbers, we can identify 0.33. We can now identify 0.330 as a smaller number. So that means it's 0.45. It's no use to us. We're not going to need it. Alright, so we've got the number of moles, but moles isn't really any good to us. We've got to convert that over to grams, so we're going to go that final step from moles to grams. Okay, so we can produce 0.330 moles of Cl2. And we're going to just convert that over to grams. 1 mole of Cl2 is 71 grams of Cl2. Moles cancels out moles. And we calculate that to be 23.4 grams of Cl2. So from those two reactants, 0.45 moles of manganese dioxide and 48.2 grams of hydrochloric acid, we can produce 23.4 grams of chlorine gas. Alright, and once again, even though the question doesn't ask us to, let's go ahead and figure out how many grams of excess we will have. So we know that HCl was our limiting reagent. Oops. And manganese dioxide was our excess. So let's see how much manganese dioxide we would have left over at the end of this reaction. So if we can make 0.45 moles of manganese dioxide, I'm sorry, not 0.45 moles, that's how many we started out with. If we had, or could make 0.330 moles of chlorine gas. Let's see how many grams of manganese dioxide that equates to. So 1 mole of manganese dioxide is 1 mole of Cl2. Got that from the balanced equation. And once more, manganese dioxide is 86.9 grams for every 1 mole. And let's label our units, Jonesy, old boy. Cancel, cancel. So we would be required to have 28.7 grams of manganese dioxide. Alright, so how many grams did we start with? Well, if we look up, it's in moles. So we can't subtract those two numbers because they're not the same units. So we need to convert that guy over to grams as well. So we have 0.45 moles of manganese dioxide that we started with. And 1 mole of manganese dioxide still weighs 86.9 grams. So 0.45 times 86.9, that means that we started with 39 grams of manganese dioxide. So if we started with 39 grams and we used up 28.7 grams, that means we're going to have 10.3 grams in excess. Let's make that 39.0 so that we have the right number of sig figs of excess manganese dioxide.